It all starts with a spark, which forms an idea, followed by curiosity, creation, and invention. And this little doodad of an invention right here, well, it might just change my life, but we should start from the beginning. So, I got a problem, and I suspect you got the same problem too, even if you don't know it yet. Specifically with my 3D printer, which is like surprising because like 3D printers today, they just work and do everything for you, from loading filament to pressure advance to bed probing to even cleaning the nozzle. Well, maybe not so much that last one. I mean, my printer does have a nozzle wiper for getting rid of all the loose bits and a scrubbing plate for cleaning the tip for bed probing. But the rest of the nozzle is, well, just kinda on its own. And slowly but surely, print after print, it builds and builds and builds until one day it's just a ball of filament in the shape of a nozzle. But I got an idea, and actually came from the printer itself. Like I mentioned earlier, this thing has a scrubbing plate, which is a piece of stainless steel with some perforated holes in it. Basically a cheese grater that slices off cauterized filament and leaves you a perfectly clean tip every single time. And I was like, well, can't we just do that, but with like the rest of the nozzle on the sides and the taper? All we need is a piece of metal that is the exact shape of the nozzle, and then throw in a couple clearance holes to form cutting edges and flutes for the material to have somewhere to go. And aside from how to actually make it, I can't think of a single reason why it wouldn't work, so let's go for it. Now, I'm sure some of you think I'm exaggerating or making a bigger deal out of nothing. This problem's already solved, bro. Just buy a brass brush, heat up that nozzle, scrub, you're done. And yeah, that does work, but it has some pretty major downsides. 1, you gotta scrub the thing for like a solid minute plus. 2, you're gonna burn your fingies pulling out that silicone sock. And 3, you very much risk damaging or destroying your thermistor wires, which many people have done in the past. And personally, I just want it to be quick and easy. A quick 5 seconds, twist, done, straight back to printing. Maybe a pipe dream, but we'll see. And like, seriously, we will see. I do not know if this is gonna work. That's the whole part of inventing. Like, at the very end, you could just discover there's a reason why no one's ever done this before. I really hope not. In the background, I've got the stock prepped, a little bit of O1 tool steel that I just happen to have lying around. For making the fancy holes, luckily, Makera recently sent me their Z1, which at first blush, I was kinda like, this is just a cute little toy, but now, I'm not so sure. But right off the bat, we do actually have a problem. I meant to hold the stock in an ER32 collet block, but the Z stack up, well, turned out to be so high that I don't even have room to probe the part. Switching to a pair of V blocks helped with the Z height problem, but now all of a sudden the diameter is too small. So I have to go back to the closing mill and turn down a larger piece of stock. And now we are finally ready to go, which we're gonna start off with an 1/8 inch spotting drill. And right off the bat, I stall the spindle twice. Yeah, first impressions, just kind of a toy. But, I eventually got it to work, slowed that speed way down, and then came in with a 1.2 millimeter PCB drill, and after that, roughed with an 1/8 inch 2-flute ball mill. And once again, I'm hitting that E-stop because that ball mill does not want to cut steel. It is making all sorts of racket. And so we're going backup plan, which is to do the entire thing with this teeny tiny 1 millimeter ball mill. And it worked. I mean, surprisingly, yeah, it just worked. Don't get me wrong, it took like 2+ hours, and while it was doing its thing, I took the time to order some proper end mills for cutting steel. Stay tuned for that. I also dirtied up a nozzle to do a quick test, and the results are, it works. Or does it work? I mean, don't get me wrong, you put the tool on, a couple quick twists, and the plastic shears right off, exactly how I imagined in my mind. But I'm not so sure because that filament wasn't baked and cauterized on like it would be from a 10-hour print. So maybe not the perfect test, but a good proof of concept. And I'm also a little bit uneasy. I just don't feel like I got that taper angle correct. I've been trying a whole bunch of different measurement methods. I started off just using calipers and some high magnification, then switched to taking high-res photos and trying to measure in CAD software. But every time, I just get conflicting numbers, guesswork left and right. I just don't know. So I'm gonna go back to basics and we're gonna do a whole bunch of test cuts in some aluminum. And let me tell you, I mean a whole bunch. I did 60 degrees, 59 degrees, 58, 57, 56, 55, 54, 53, and not a single one of them is a smoking gun. I mean, don't get me wrong, it's a little bit positive because we can see that cutting action in action. But in the end, I just kind of went with 55 degrees because it seemed to be the best. Cross our fingers. But I did manage to break the mill while doing this. Yeah, the tool changer, the collet, well, it just stopped holding tools altogether. Turns out my fault though, I had been not pulling the lever all the way down when changing collars, and apparently that was slowly unthreading the drawbar. But hey, on a positive note, the machine performed so much better in aluminum, taking just 20 minutes per cycle, which was a real godsend because there was a lot of them. But the real hero of this whole shebang has got to be this 1mm ball mill they sent me. This thing did the cuts and steel and the dozen or so cuts in aluminum, and it's still going strong. I thought I was gonna break this on the first op. Now back in my apartment, I've actually been hauling this machine to and fro between weekends, which is a crazy thing to say about a CNC machine. And while I'm still not confident in my dimensions or angles, I'm out of ideas and time, so we're just gonna go with it. But hey, at least this time I have the proper end mills. 4 flute stub length ball mills, which will be so much more rigid and be able to push far harder. This time around though, I didn't spot drill and really almost regretted it because that PCB drill came so close to snapping right there. But hey, I'm actually shocked that these 10-cent drills able to do as well in steel as they did. And the final result, rather respectable, I gotta say. And a quick Sharpie test shows us that it is working absolutely not at all. What? What is going on? How, are we going backwards? Well, it turns out I kind of cut a 65-degree angle instead of a 55-degree angle this time. And the sad thing is, I like triple checked it, and every single time I was like, yep, 65 degrees, that's the right angle. What an idiot. But hey, it did give me the chance to push the feeds and speeds even harder. I managed to get the time down to like just over an hour, but half of that is literally just the finishing pass, which is doing a microscopic 10,000th of an inch step down. Oh, and if you're wondering what all that camera shake is, that's actually my 3D printer going to town on a 30-hour ABS print trying to dirty up that nozzle. But it's shaking side to side and transmitting through the floor and into the CNC machine. Pretty wild, but you know, after a quick facing cut and doing a side profile on the closing milling machine, you would think we'd be ready to go, but you would be wrong, sir, because we can't be using this tool with our bare hands. What am I, a barbarian? No, this thing needs a proper nozzle. So I put the FDM printer to work knocking out a handful of prototypes. I was kind of inspired by some fancy awl handles that I've seen in the past, but I decided to add a little bit of fluting on the side for a bit of pizzazz and a bit of extra grip. Now, the first version, well, it kind of looked too much like a mushroom. The second one looked better, but wasn't just perfect for the fit of my hand. The third, spot on. Now for the final print though, I did it in resin, and I just love this method. Knock out the prototypes on FDM nice and quick, and then do the final product in resin, which just feels and looks amazing in the hand, at least once you give it a quick sand and a clear coat. You'll also notice that this baby's a 2-piece deal. I tried to get a little bit of fancy and make the back a spinny bit. It's a very technical term. You see this feature all the time on really small screwdrivers, and I just always love it. It uses 2 little bearings in it. One is just a plain bronze thrust washer, and the other is a proper roller. As for the screw, it's just a piece of brass, 3 diameters, a thread. I rounded the head with a quick file, and then a slot and a slitting saw. Now, I actually was kind of proud of this piece though, because I hit all of my dimensions within 1,000th of an inch on a milling machine with no DR out. So, you know, not bad. But, what's next? So now we are all ready to go, except for the fact that I spilled super glue literally all over the handle at the very last second. Why, God, why? So rewind, do all that again, but this time being extra super careful with the super glue. And now we are finally, cross my heart, hope to die, no more delays, ready to test this baby. Now in the background, I mentioned I've been printing off one of my Cydio knockoff crates that's been going and get the nozzle nice and stinky, full crust action just the way we want it. We push on the tool, give it a couple quick twists, and it's totally working. After just a few passes, there's just a handful of bits clinging on for dear life. I throw the tool back on there, twist a couple more times, canting it side to side, and it's completely clean. Now, I will be honest though, it's not a perfect result. It's good, but not quite perfect. Like I said before, I wanted this to be like a 5-second operation, and it's more like a 10 to 15-second operation. But hey, it's way better than that brass brush, and that's a hill I will die on. Plus, I think we can get it a lot better. That said, there is a problem that I haven't actually told you yet. So Bamboo, in all their wise wisdom, decided to make every single one of their nozzles a different size, diameter, angle, etc. Especially the standard and high flows are wildly different. You actually saw me machine the high flow version in the first sort of test cuts. But even like the 0.2 and 0.4 millimeter nozzles seem to differ. I used the final cutting tool on a 0.2 nozzle and it sort of cleaned it up, but just not as thoroughly as the 0.4, leading me to believe that that angle is just ever so slightly different. But, you know, I might honestly just reach out to Bamboo and see if they'll give me the dimensions for the nozzles, which I should have done from the beginning, but there was no way I was ever gonna see that the measurement part of this was gonna be the hard part. But hey, if you wanna download, use, modify, do whatever with any of the stuff you've seen in this, all the files, including like the cool little handle and the modular storage crates I have, are gonna be available for download over on my Patreon. Completely free, no paywall whatsoever, and it comes with the CAD files. I've probably already said that, blah, 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 blah. Oh, that said though, if you do wanna support me a little bit and throw me a little bit of cash every now and then, like these amazing people do, that would be awesome. It would literally make my month, at least. Maybe even my year. But what else? Oh, leave me a comment. Let me know. Is this a tool you would find handy? Do you got any ideas on how I can measure or make it better? Or do you think it's stupid and overly complicated? Seriously, I enjoy a good burn every now and then. My favorite one from the last video was actually Temu ass build, waste of filament, waste of time. Next time.